Jai Hind student, I am Dr. Anand Tyagi from Ajay Kumar Garg Engineering College, Ghaziabad. Today I am going to deliver my lecture on the vector differentiation and based on the vector calculus, and this is lies in the syllabus in the AKTU and whose code is BAS 103. Today I am going to represent my lecture for the vector differentiation. In the previous lecture I explained what is the role of the vector differentiation and what is vector. First of all, contents of the today lecture are gradient of a scalar point. First of all, I explain what is gradient and what is the role of gradient in our engineering and technology, and point function, what is point function, I elaborate in this lecture. Divergence of a vector point. First of all, I explain what is divergence and what is the role of divergence. Next, curl of a vector point. So today lecture is very most important for the unit number 5 for the engineering student, gradient, divergence and curl. What is the role of this topic, and in the finally some application of the above topic I elaborate in the end of the today lecture. And directional derivative, how to calculate directional derivative and what is the role of directional derivative, I explain briefly here, and question based on the above topic. So today lecture is very most important and interesting for the BTech student. A recommended book, AKGEC, Advanced in Engineering Mathematics, Marais de Weir, B.B. Ramanna and B.S. Grewal. Student can be opt any one of them. Now first of all, I explain what is the point function. A variable quantity whose value at a point in a region of dependent upon the position of the point is called scalar point. Suppose we have a point here, right? The role of this point in the 3D will be x, y, z. In this way we can calculate the position of this particle in the form of the vector form, and this is scalar form. So this is denoted by xi cap plus yj cap plus zj cap. So in this way we can calculate the vector position and the scalar position of this vector. So in this way we can calculate the position of the vector, right, in the form of the point function, and that is known as the point function. I explain briefly here, right, what is the role of this function, I explain here one by one. So first of all, I explain here a variable quantity whose value at a point in the region of space depend upon the position of the point is called the point function, right? And what is the role of this point function? With the help of point function we can calculate the position of the particle in the space. There are two type of point function, right? First is scalar point function, I explain here, right? And second is the vector point function, right? In the just now I explain what is scalar point function and what is vector point function. Scalar point function, if to each point p, x, y, z in the region R in the space there corresponds a unique scalar fp, then f is called scalar function. For example, the temperature distribution in the heated body, density of the body and potential due to the gravity are the example of the scalar point function. Now next is vector point function. What is the role of vector function? Suppose I write a point p r x y z, then this is called the vector point function and denoted by here vector r is equal to x I cap plus y j cap and plus z k cap, and this is the position of the particle in the space. In this way we can calculate the velocity of the moving fluid, gravitational force are the example of the vector point function. Now vector differential operator del, that is very most important, the part of the vector calculus. It is depend on the partial differentiation. In the previous lecture I explained how to calculate the partial derivative in different ways, right? In the with respect to the variable. Partial differentiation use if function contains more than one independent variable, then we use the partial differentiation. Now what is the vector operator here, right? Suppose we have a 3 dimension here, right? Suppose this is x, this is y and this is z. In this way we use the direction I cap, in this direction we use j cap and in this direction we use k cap. The motion of the particle in x-axis denoted and defined by all derivative with respect to x here, right? In the same way motion of the particle in y direction denoted by del y over del x, and in the same way del over del z. So with the help of these axes right? Suppose we take the summation of these x's, so result will be the vector operator here, and result will be here, right? I del over del x, right? This is the motion of the all particle in x-axis direction, this is the motion of the all particle in y-axis direction, and this is the motion of direct, right? And that is denoted by operator del. So in this way we can calculate the operator form, and student keeping in the mind when we solve the problem with the help of del operator, and value of del will be this. Suppose I wants to calculate the gradient of a scalar quantity, right? What is the role of gradient, suppose, right? So we conclude here, suppose phi be a scalar vector point function here, and its gradient is denoted and defined by grade phi. And what is the grade phi and how to calculate? So grade phi means del phi, right? And what is the value of del? Value of del is the I del over del x, del over del y plus del over del z. I explained just now, right? How to calculate, right? Grade phi is equal to del phi. Shortly, in the student keeping this formula and keeping in mind when we solve the problem and calculate the gradient. Gradient means normal to the surface. Suppose I have a plane, right? And this plane, this will be the perpendicular to this plane. Yeah, we can say that this pen is the normal to the my hand. Yeah, we can say that I am normal to the surface because I am standing on the floor. That means I am gradient, right? Gradient means towards the outside the surface. In this way we can calculate the gradient of a function. Suppose we take an example here. Suppose this is the phi, and we find to calculate the gradient at a point this, right? Suppose this is the surface, and this is, there is phi, and value of phi at this point 1, -2 and -1. Then how to calculate? Question is that. So in this way we can calculate here by using the gradient. A gradient means normal to the surface. So first of all, value of gradient, grade phi is equal to del phi. And how to calculate? So how to calculate value of del is this, and that is phi, right? So what is the role of this? First of all, so first of all, in the place of phi, I write here differentiation of phi with respect to x, differentiation of phi with respect to y, and differentiation of phi with respect to z here. So what will be the conclusion here? Differentiation of x, this function with respect to x, 3 to the 6 xy, and this is 0, 3 to the 6 xy, and this is the 3 to the 6 xy. So result will be here with the help of this component, and result will be here this. So in this way we can calculate, and putting the value of 1, -2 and -1 in this point, and calculate the gradient of this function. In this way we can calculate the value of this function in this way, right? So how to calculate, we see that very carefully. And geometrical meaning of the gradient, right? What is the role of the gradient? We see that the equation phi x y z is equal to c represent a family of curve surface different value of the constant, right? Then phi x is the vector normal to the surface, right? That is denoted by phi y, and this is vector normal to the surface. I explained just now. Suppose my hand is this, and this is the normal to the surface, right? And denoted by gradient phi. Find the unit normal surface x y cube z cube is equal to 4 at this point -1, -1 and 2. So what is the role of normal to the surface here? First of all, we see that, right? First of all, we calculate the phi is equal to this. This is the function, right? And now calculate the del phi, right? Del phi means value of del phi is this, right? And putting the value of here phi, right? Because differentiation of 4 is always 0. So we do not take here 4. So differentiation of this with respect to x, right? Y cube z square, and differentiation of this with respect to y 3xy square z square, and differentiation of this with respect to z 2xy cube z. Now we find to calculate the normal at this point. So putting x y z, x is equal to -1, y is equal to -1, and z is equal to -1 in this form. So if we put up x is equal to -1 and y is equal to -1 and z is equal to 2 in this form, so we get -4i -12j and plus 4k in this way. So in this way we can find out the normal vector, that is known as del phi. Now question is that how to calculate the unit vector, right? In the previous lecture, suppose I write this n, right? Vector n. that is known as unit normal vector. Now our aim is calculate the unit normal to the vector. So study in the 12th level, student study in the 12th level, right? Vector n is equal to, right, given, right, and how to calculate n cap. So n cap is equal to vector n upon this, right, and this is known as the grade phi, right, and this is the magnitude of the grade phi that represent the maximum normal to the surface. So in this way we write here del phi, and this is the magnitude of the vector del phi. So 4 4 is 16, 12, 144 and 4 4 is 16. Suppose we can calculate here, right. So what will be the conclusion here? We see that and calculate the result. In this way we can calculate the value of the unit normal to the surface. Now find the angle between the two surfaces. Suppose this one of the surface is this and this is the surface of this, right. So what will be the angle between two surfaces? So first of all I take this is phi 1, right, and this is phi 2, and calculate the value of the phi 1 and phi 2 with the help of the gradient. First of all, right, this indicate that how to calculate the vector from the surface. This is a surface, right, and how to calculate vector with the help of gradient. So with the help of gradient, first vector occurs this minus 4i minus 2j plus 4k with the help of the grade, right. Now this is second surface, right, this is considered by phi 2, right. So how to calculate? So first of all calculate gradient of this surface, and gradient of this surface at the point of this will be this, and this is denoted by vector n2, right. So what will be the angle between two vector? So student study a dot b is equal to, right, modulus of a, modulus b and cos theta. So how to calculate cos theta? Cos theta is equal to a dot b upon modulus of a, modulus of b. In this way we can calculate the dot product of two vector. Student study in the 12th level, right. 4 4 is 16, I write here, right. 2 2 is minus 4, I write here, and 4 1 is 4, I write here, and magnitude of the both is right here. In this way we can calculate the angle between two surface, right, and that is denoted by cos theta is equal to 8 upon 3 root 21. Yeah, we can say that theta is equal to cos inverse minus 8 upon 3 under root 21. In this way we can calculate the angle between two surface. So right, suppose I have the two surface, this is, and how to calculate the point of contact and how to calculate the angle between two surface at the time of contact area, at the time of incident. Suppose in the space two particles are moving towards to each other, at what point they incident to each other, right. So we can calculate with the help of the gradient of the surface, right. Now another topic is directional derivative. Directional derivative is denoted by d dot d, and what is the role of that directional derivative? We can, the component del phi in the direction of, the component of the del phi in the direction of a vector is called the directional derivative of phi in the direction of the given vector, right. Suppose we have a del phi is equal to, denoted and defined by here, right, del phi is denoted and defined by here vector n. Del phi is equal to vector n in the direction of, right, another vector a. So we can calculate dd is equal to vector n dot a cap. In this direction we can calculate the directional derivative of the given vector. In this way we can calculate here del phi dot a cap. Del phi means directional derivative of a vector along the vector a, yeah, in the direction of a, where a cap is the unit normal vector. Use of the directional derivative. So first of all, the directional derivative is the rate at which the function change at a point in the directional of the given vector. In this way we can calculate the position of the particle in the space. If we are find the rate of change of the function in specified direction, we shall calculate the directional derivative. In this way we can calculate with the help of the function, right. Now explain here through the example directional derivative, how to calculate directional derivative here. Suppose find the directional derivative of this function. This is the surface at this point in the direction that is a. First of all, right, student, keeping in the mind, suppose in the along this vector, this is a vector And how to calculate vector A cap here, right? So del phi dd will be here, right? Grade phi dot A cap, right? So how to calculate? There are two components. First is the grade phi and second is A cap. So grade phi is calculated with the help of surface and A cap is calculated with the help of this vector, right? So student, keeping in the mind, that is very simple calculation here, and I calculate step by step, that is del phi. How to calculate the del phi, right? The value of del is this and phi is this, right? That means differentiation of phi with respect to x. So what will be the result here? The result will be 2xyz plus 4z square, right? Differentiation of this with respect to y. So what will be the result? X square z j cap, because differentiation of this is 0. In the same way, differentiation of this with respect to z. So what will be the conclusion here? Conclusion will be x square y and 8xyz k cap. Now del phi at the point. At which point? And point is this 1 minus 2 and 1. And right, we put up value of x and value of y and value of z in this place and calculate the value of n cap is equal to j cap plus 6 k cap, and that is known as vector n. Vector n. Now our aim is calculate the directional derivative of dd. So for the dd, first of all we calculate the A cap, right? And formula of A cap is equal to, right, vector A upon magnitude of vector A, right? So 2i minus j minus 2k, and magnitude of this vector will be the 4 plus 1 plus 4 is equal to 9. So this is known as A cap. So in this way we can calculate the value of A cap, and remaining calculation is here, because our aim is to calculate the directional derivative at this point. So how to calculate? The how to calculate formula is del phi dot A cap, and value of del phi is this, right? And value of A cap is this, right? Suppose we can calculate the value of here. So we can calculate the dot product of two vector, right? First is del phi and another is A cap, and result will be this, and with the help of this we can calculate here minus 13 upon 3 is the directional derivative of this function. Now directional derivative is calculated with the help of the normal phenomena here and change of the function in the specified direction. Now question is that what is the role of maximum flow of the directional derivative and what is the role of the maximum flow of the directional derivative? Mathematically, directional derivative is denoted and defined by the del phi dot A cap. In this way we can calculate is it is a dot product of two vector, right? It is a maximum when both vector are parallel, right? That is most important part of the today lecture, right? Now thus calculate the del phi and in the same direction, and dot product of the vector can be calculated. Maximum value of the directional derivative occurs in the direction of del phi, and that is denoted and defined by the magnitude of the del phi. Magnitude of the del phi. In this way we can calculate the maximum gradient. Now I calculate this with the help of the numerical problem. Find the greatest rate increase of this. So first of all we find the gradient of this surface at this point and calculate the magnitude. Gradient phi is this, and del phi will be here, value of del is this and value of phi is this, right? So first of all we calculate the partial derivative with respect to x, y, z here, right? So differentiation of these terms with respect to x will be 2xyz, right? Plus k 4z square. With the help of y, x square z, and with the help of z here this. So in this way we can calculate the partial derivative, right, with in direction x axis, y axis and z axis, and a component of this at this point 1 minus 2 and 1. We put up the value of x, y, z in this problem and calculate the value of maximum directional derivative here. So this is the j plus 6k cap, right? How to calculate the maximum flow, and maximum flow is the magnitude of this, right? And result will be 1 and plus 6 square 36 under root 37. So in this way we can calculate the directional derivative of the maximum normal to the surface. Now divergence of a vector point, that is very most important for the engineering student. What is the role of the divergence? Divergence means spread your fumes, yeah, is spread of anything, right? Suppose sun gives us the light, that means sun divergence the light towards earth, right? The directional derivative of a vector point is denoted and defined by the divergence f, right? And f is a vector point function and denoted by f1 I cap plus f2 j cap plus f3 k cap. In this way we can calculate the divergence of f is equal to del dot f. Del dot f, del means this value and f is a vector point function, then this is the basically divergence is the dot product of two vector, right? Suppose we can take dot product of two vector, first is the del operator and another is the vector. So what is the result of this, right? With the help of the dot product, so del f1 over del x I dot I1, right? And del f over del y, f2 over del y and del f3 over del j. Student, keeping in the mind when we solve the problem in future of the divergence of a vector point, then we use del dot f, right, and calculate the value here. In this way we can find the value of different part of the numerical. Physical meaning of the divergence, right? Physically, if the divergence of a vector quantity represent the rate of change of field strength in the direction of the field. Physical meaning of the divergence, right? If the divergence of a vector point positive at a point, then something is diverging from a small volume surrounding the point. If it is negative, then something converging into the small volume of surrounding that point. I explain with briefly here. If the divergence at a point is 0, then the rate of sometime entering a small volume surrounding the point is equal to which is leaving the volume. Physical meaning of the divergence. So first of all we see that by the postulate, right? Suppose a point is spread something, so that means positive divergence, right? Suppose some is entering at a point, so this is called negative divergence of the point. Now that is 0. Suppose something is enter there and something is fragrance there, right? That is known as the 0 divergence. So in this way we can define into 3 part of the divergence: positive direction, divergence, negative direction and the 0 direction. In this way we can find the divergence of the meaning. Physically, meaning of the divergence by the example: divergence positive, that is the divergence positive, that is divergence 0, and then that is divergence negative. We can explain with the help of the moving of a fluid, right? Suppose in our body the blood is flow, right? So that is the example of the divergence. Suppose our heart is pumping the blood and oxygen, and that is the example of the divergence for our body. Now how to calculate, find the divergence of a vector point. This is a vector point function, and how to calculate the divergence of this, right? So first of all we can calculate the del dot f here and calculate the value of this, right? I dot I v, that means component of I cap differentiate with respect to x here, component of j cap differentiation with respect to y cap, and component of k cap differentiation with respect to z. In this way we can calculate the divergence of a vector function. And student, keeping in the mind, divergence of a vector is a scalar quantity, result is scalar quantity, right? That is the most important part of the today lecture. Student, keeping in the mind, the divergence of a vector quantity is a scalar solenoidal vector point. What is the role of solenoidal and what is solenoidal? The vector field whose divergence is 0 called solenoidal. Suppose del phi, del v is equal to 0, that means v is a solenoidal, that means there is no loss of fluid, that is called equation of continuity, equation of continuity of the fluid, right? Suppose I have a vector here. Now we want to check that this is a solenoidal or not. So how to calculate? So first of all we calculate here the divergence of this vector point function. And how to calculate divergence? Del dot v should be 0. So first of all we calculate here, right, with the help of the differentiation of this part with respect to x 0, differentiation of this part with respect to y is also 0, and differentiation of this part is with respect to z is also 0. So we can say that divergence of this vector point is the 0 and v is the solenoidal vector point function, right? Now another is point to the lecture is the curl. How to calculate curl and what is the role? Curl means movement of a vector, right? How to movement? That circular path, right? Suppose a particle moving in this way, right? So we can say that that is represent the curl of this position vector, right? Curl v curl f is denoted and defined by the vector del cross f. Right, how to calculate the cross product of two vectors? Student study in the 12th level, and f is the vector point. Now, how to calculate? This is calculated with the help of the determinant. That this is ijk, and this is del x over del x, del y over del z, and del over del z, and this is f1, f2, and f3 here. With the help of first row, I elaborate it and I explain it in the previous lecture how to calculate the determinant, right? And result will be this. Right, if curl of a vector is 0, that means vector is irrotational. Student, keeping in the mind, when we solve the problem in the future, then calculate the problem. Right, now our problem is, this is the vector point function, and how to calculate the curl at a point -2, 4, 1. So first of all, we calculate the del cross f here, right, with the help of the determinant, and calculate the value of the this result will be the this. This is the curl of this vector, and with the help of this we can calculate the curl of the vector, and at which point? Point is -2, 4, 1, and result of this will be this. Right, the physical meaning of the curl, right, curl means the extent rotation in the field about a point. Visually image placing of a pedal wheel and the wheel of the this. Suppose this wheel move in the this direction, right, this is represent the n vector, that means unit normal to the surface, and when we roll about this direction, that this fluid move in the anti-clockwise. Right, so we can calculate the rotation of this. Right, windmill is the example of the curl rotation. Irrotational vector point, suppose curl of a vector point is 0, we can say that that is irrotational. And how to calculate? Right, suppose a vector is the irrotational, and what will be the value of ABC? We see here very carefully. So we calculate here a numerical with the help of irrotational. Right, suppose vector is irrotational, so first of all we calculate del cross f, and del cross f is calculated by, this is the first row and this is second row. Right, and this is the part of the vector point function. Right, suppose this will be 0 here. Right, so this component will be 0 if c plus 1 is equal to 0. Right, we see here, so c plus 1 is equal to 0. Right, so c is equal to -1. Right, suppose this is equal to 0, so a is equal to 4 and b is equal to 2. So in this way we can find the value of the ABC, for which right, this problem is arise in the GATE examination of the BTech student. Right, so what is the role of this irrotational vector? We can calculate here, right, with the help of this. Right, suppose we can comparing on the both side. So right, this is compared by this, and this is compared by this, and this is compared by this. So value of ABC 4, 2, -1 here. So in this way we can calculate the value of the ABC by using the curl. Right, so in this way we can calculate the how to calculate the part of the line. In the next lecture I explain what is the line integral and what is the role of the line integral. Now brief of the today lecture. Today lecture I explain 3 most important topic. Right, first of all is the gradient, grade phi. Grade phi means del phi. Next is divergence. Divergence of a vector f is denoted and defined by del dot f. And next is the curl f. Curl f denoted and defined by del cross f. Right, there are 3 things. First is gradient. Gradient means normal to the surface. Gradient means normal to surface, that is known as, right, this is, right, divergence. Divergence means flow of fluid. Flow of fluid, that means that is known as, right, and that is rotational, that is known as rotational. Right, so there are 3 things. First of all, normal to the surface. Second is flow of the fluid, right, and another is the irrotational and rotational fluid. To today lecture I explained today lecture in the divergence, curl and gradient of the scalar and vector point function. If student have any problem, then they can contact me. I will try to solve their problem. Jai Hind.